Hello everyone, my name is Elliot Weiser. I'm here with Rob Whitlock, and today we're going to talk about how we use BDD to scale up test coverage at SiriusXM Pandora. So an overview of what we're going to talk about today. First, we'll talk about the state of testing as it is today and some of the goals that we have for improving on the status quo. We'll also talk about BDD, some of the benefits, and also some of the challenges and risks of BDD. We'll also cover the tooling that we've chosen to adopt BDD at SiriusXM Pandora, but also some of the tooling that we've developed in-house to enhance BDD while simultaneously mitigating its risks. And with that, we'll also discuss some of the future directions that we are taking, our specific approach. So here are some of the goals that we have. First of all, testing is about application stability. In order to make it easier for devs and testers to adopt best practices, we want to provide a paved path. And to that end, we want as much standardization as possible. With standardization, it'll be easier to provide observability. And with observability becomes auditability and eventually accountability. Though I would say observability is the main goal there. With an observable solution, it'll also be easier to identify gaps and skips in test coverage from a bird's eye view. We also want to adopt a push left mentality as much as possible. And that means we want to reduce the time it takes to implement and maintain test cases. We want to empower developers wherever possible to write and run tests on their laptops. And we also want to make sure that tests provide rapid feedback to developers, whether it's in a CI environment or locally. And that happens to be the hallmark of a good test, is that it also provides rapid feedback. I'd also say that one way of characterizing this goal is to break down silos as much as possible and to foster good collaboration between teams. And overarching all of this, I would say the goal is to create a foundation for scalable test infrastructure. So with that, I'm going to hand off to Rob, who's going to discuss the importance of BDD.
Hey, thanks, Elliot. Hey, my name is Rob. BDD, you ask? That sounds just like TDD, but with extra steps. You're not far off, I think. So first of all, the benefits of BDD. Like TDD, which is test-driven development, there is a focus on testing the public-facing behaviors of a system. BDD, of course, behavior-driven development, extends TDD with very intentional cross-functional collaboration. The goal is still to write a failing test first, but with the extra benefit of collaborating to kind of discuss that test first. And in the end, you end up with some living documentation, documentation that also doubles as code and can provide really good transparency and feedback. And many testing frameworks already support a behavior-driven approach. So it's just seemed like a natural fit for us. But of course, BDD has risks. It is largely a communication process, and so that does bring some overhead. And as such, it can improve communication between teams, but that trade-off gives you a little bit more of a complicated development process. One of the hallmarks of BDD is that it requires discussion between collaborators and stakeholders. And so as such, just using the tools themselves does not actually mean you're practicing BDD unless you are collaborating. That's the key piece here is talking about the behavior that we all want to see in our product. So the paved path. So the first thing we have is the gherkin language. Gherkin is a language of BDD that just can describe behaviors in plain English. And because we've talked about things in plain English, we can remove technical barriers. We're not talking about Java code or Python. We're just talking about English. So that can really create transparency between collaborators. Product and management may not be the most technical of people, and so being able to talk in a language that everyone can understand really reduces those gaps. The basic syntax of Gherkin is given, when, then, and I think that is really easy for most people to understand. It is probably how they think about requirements anyways. And so having that really simple language encourages teams to focus on building what matters. Once we kind of have a lot of these technical things removed, we can talk about the essence of the behavior of what we're trying to test. So, just a brief overview. Typically, we would have features that have scenarios that have steps. In this particular feature, we're talking about a toaster, and our scenario is making toast. So the steps would be, given the toaster is on, when I insert bread in the toaster, then I have toasted bread. I think we can all agree that is really what defines the behavior of a toaster, very simply. So the next thing we have in our tool set is grammar validation with Antler. Because the gherkin syntax is so minimalistic, we really just have given, when, and then with a bunch of freeform text afterwards. Without being careful, you can end up writing the same steps in different ways. For example, the listener is signed in versus the user is logged in. Mean the same thing, but to the computer and to everyone else, they're different. So we can think of a product's gherkin, the collection of all their language, the collection of all the gherkin for a product can be considered a domain-specific language. And so there's a tool called Antler, another tool for language recognition that we can use to essentially validate that language. It has the benefits of keeping the terminology consistent. For example, listener is not a user, is not a subscriber. We only talk about listeners in our grammar. This can help one of the drawbacks of Gherkin, which can be that native speakers may have a little bit of a challenge with it, and this can allow them to write Gherkin with confidence because, for example, users aren't the thing, it's listeners. So the grammar engine will validate them and say, nope, you can't say that, only listeners. Antler is an industry standard, and it has a bunch of IDE plugins and some great documentation. So best to use a tool that's already written than write your own if it's there. One of the other tools we've written is a proto-gherkin tool, essentially generating gherkin from an IDL, like an interface definition language. In this case, Google's protobuf. The goal there is to really reduce the amount of effort it takes for someone writing a service to get some tests going. And so if we have a service like the login API, for example, that has one RPC call, just login, and it takes a login request and returns a login response, we can generate a very simple gherkin to kind of validate that call at a high level. So we might say something like, given a valid login response with all the parameters are set, when the login method is called, then a valid login response is returned. This just really gets to the heart of, on a large scale, of what this API should be doing. You don't necessarily know how, but we know what the behavior is going to be. We get a valid login response. Cucumber. That is kind of the next tool that we can talk about. Cucumber, we looked at a variety of different BDD frameworks, and Cucumber is the only one that I could find that separates the test definition from the implementation. If you think about the definitions as the scenarios, which would be written in Gherkin, then you have this native implementation in the glue code, is what that's called. And that really helps you practice TDD in that you can write your tests before implementing them. You can collaborate on the scenarios and get your language set and really think about the behavior of what you're going to test with your stakeholders and collaborators before even writing any native code. Another side benefit of that is you can use the same Gherkin on multiple platforms. It can essentially serve as a cross-platform testing tool. That was one of the challenges we had at SiriusXM Pandora. We were developing an app for iOS, Android, and web, and wanted to use BDD. So that was one of the benefits, is that we could write the Gherkin once and implement it in 3 different ways to test different platforms. It's an industry standard product. It's been around for a long time. So there's lots of help available and lots of patterns that we can use to write great Gherkin. So, with any good tool, there's always some barriers to adoption. With Cucumber, there are some. And the first one, of course, is that it's just another layer of abstraction. in your framework. Again, talking back to earlier about if you're just using the tools and not the process, it doesn't really help, because you do have this extra layer. But if you're communicating and collaborating, then it really can pay off. Mapping that English text to the glue code can be very maintenance heavy. And of course, having this free-form English-like syntax can be challenging. It can produce a lot of variations unless you have some guardrails. That was kind of the antler piece we were talking about earlier to mitigate that. And it could be hard for non-native English speakers. And one of the implementation challenges is there's no way to, or provided by Cucumber anyway, to maintain this state between your various steps. That's something you have to implement and figure out. And the implementation of that can get a little messy, but I think the trade-off of having that collaboration between the stakeholders makes it all worth it. So here's just a brief overview of how Cucumber works. We'll talk about a feature that's maybe a little more relevant than a toaster, signing in. So we have the scenario signing in. The step is given the listener is not signed in. When the listener signs in with valid credentials, then the listener should be signed in. So that's the feature. That's the gherkin. And on the right side, we have the glue. In this case, we're just mapping this first step. And you have an annotation. This is Java, I believe. You have @given, the listener signs in with valid credentials. So when Cucumber runs, it reads that first statement in the feature file and then tries to find an associated mapping with it to execute that code, which calls this sign-in method, which eventually calls the test framework sign-in to redirect to the application under test and do the thing. So the glue code is where all the user work is really done. And so we have the gherkin glue generator. That bit of code with the glue we just looked at is where all the magic happens, really, but it's also where all the work happens. And there can be a lot of maintenance in that bit. So the glue generator aims to reduce that maintenance. It has some benefits of providing consistency across multiple test frameworks, which is a situation we had with iOS, Android, and web. So the layout of the project is the same. The types of functions you interact with are the same. So it allows some of the engineers to switch projects easily and kind of say, oh, here's my glue. I understand where that is. So the basic algorithm is to read through each step of the gherkin and generate two classes, a disposable step file, which kind of has that mapping from, given I have a logged in user to some function. If your gherkin stays the same, that mapping should never change. There's no real reason to check that code in. But then it redirects to the user or the glue class, which is where the user would put in their implementation. That part is committed to source code. That's where all the work happens. And the cool thing about this setup is that when the gherkin changes, all this new code is going to be generated and potentially deleted. Steps are changed, steps are removed. The glue generator should handle kind of dealing with all those steps. And your source control management should keep track of those things for you. Say, oh, I deleted this file, I added this new one. That can be really powerful when you have a large body of steps, like we currently have something, 1,000 steps maybe. So any kind of refactoring without that, you might be terrified to do, because there's no real runtime checks in Cucumber, or compile time checks. You would just kind of fail at runtime with, oh, I couldn't find this step. So having this glue generator and connected to source control can really help you reduce your maintenance. We currently support generation in Java, Kotlin, Swift, and JavaScript. So here's just a brief overview of the classes that get generated. So the first thing you'll notice is kind of this long class name for the step class when the listener signs in with valid credentials step. It has the mapping for @when the listener signs in with valid credentials, and then it just calls this glue class function below. The nice thing about these long names is that you can just kind of in your IDE start typing the name of the step, and you should eventually match, which can be pretty nice because there are a lot of files that get generated, so keeping track of them can be a challenge without IDE search. And so we have this glue class where the listener signs in with valid credentials, It basically just has a function that by default throws a pending exception. Pending exception is a Cucumber construct that essentially notifies the Cucumber runner that the test didn't fail, it wasn't skipped, it just hasn't been implemented yet. Um, so, in good TDD practice, what happens when you use the glue generator, you end up with a set of runnable Cucumber tests that will fail. So you write some gherkin, or you have your gherkin generated from a protobuf, run it through the glue generator, and then you will have a set of failing tests to kind of guide you as to what you need to do. The BDD CLI is the next tool, and I'm going to hand this over to Elliot since this was his baby.
Thanks, Rob. So BDD CLI builds on top of the other components that were just discussed. And the intent was to provide a very easy to use interface to leverage things like the glue generator or the IDL to gherkin generator and so on. And so the BDD CLI functions essentially as a test lifecycle manager. It's configured on a per project basis with a YAML file. You just need to drop a bdd.yaml file into your repository, and then that tells the user how to run various phases of the test lifecycle specific to this project. Uh, and among the things that it does, it facilitates developer setup. And so that means that, for example, you might need to install specific components in order to get up and running and executing tests. What's nice about that is that it helps to decouple from a potentially complex testing environment, like for example, CI system. It means that there's a standard way to install components so that both your CI system and your local system are roughly equivalent in terms of being able to run tests, and that's important to make sure that if I'm a developer and I want to run a test locally and I want to triage something or debug something, then it's nice to have that freedom. Uh, Another thing that it does is it helps to deduplicate environment configuration. And so you might think that, for example, let's say I'm running tests for a web client and I need to be able to test against different endpoints. I might need to test against different browsers. And so this configuration, which lives in the YAML file, helps to make it easier to switch back and forth between different test environment configurations. The way that test selection works, it basically leverages gherkin tags. So there's a tags flag, which is part of the CLI. And this is essentially how we are selecting which tests we're going to run at any given time. And it's also designed to be extensible. So there are modules which provide additional functionality, especially for publishing, which I will talk about briefly in a moment. So the extension modules today currently consist of a gherkin extension. This is essentially to do, well, a number of things. One, to source the various gherkin files that may come from a variety of different places. So, for example, there might be a third-party repository. It might be the same repository as the rest of the application code. And it might also be an IDL as a source that is generating gherkin, like what Rob indicated, using a protobuf file to generate gherkin. There's also a glue generator extension, which makes it easier uh, to scaffold the native Cucumber test code. So that's very helpful. And there are a few publishing extensions as well. One being a test rail publisher. Test rail is not something we built. That's a tool which is provided by Gurak, but it provides basically test case management and the ability to report on test cases on essentially like a per release basis. It's very useful for that. And then there's a QE triage service, which is intended to, as the name suggests, make it easier to triage test cases according to groupings of results. And there's going to be more extensions to come as well. So because it's a CLI, there are a number of different commands that it currently provides. Starting with BDD gherkin, like I said, this is what the extension essentially does. It helps retrieve all the various sources of gherkin that are needed in order to run tests. That could be from a third-party repo, or it could be from the same repository as the application code, or it could be IDL generated. BDD-env is responsible for rendering and showing a test environment within a shell. BDD install will make sure that the workstation has any required components that it needs. BDD teardown will clean up from previous test runs. BDD setup is what BDD teardown cleans up from, and so this is responsible essentially for provisioning any resources you might need, like an emulator, a dev server, a database, whatever you might need. BDD glue is the public-facing interface for generating native test code, essentially for working with the glue generator, and that will scaffold out tests which still need to be implemented, but they are valid tests. Because there's code generation happening here, I also decided it would be a good idea to provide an opportunity to lint those files if needed. So there's a BDD lint phase for that as well. There's also BDD verify. Of course, we actually need to be able to run tests. And then BDD publish, which will take the results from the previous phase, BDD verify, and publish those results to any number of destinations. And those are generally provided by the extension modules. And lastly, there's BDD test, which brings that all together and runs them in essentially in sequence. And so when you run BDD test sort of as a one-liner, this is essentially what happens. Now, those first two blocks there, those are essentially meta phases. First one is for an auto update check. Second one is for loading and configuring. So don't worry too much about those. I'm not covering that in this talk. But the others you'll recognize from the previous slide. First, it will render the test environment. Then it will grab any sources of gherkin that are needed in order to run the tests. Then it will clean up from any previous test runs, make sure any required components are installed, set up any resources that are required, generate glue code, lint the glue code, run the tests, publish the results, and lastly, clean up from that test run. And so you can sort of picture that applied to the software development lifecycle, where you start with a group of collaborators, and you might think, well, if we didn't have any of this tooling, the collaborators would need to write all of the gherkin by hand, and they would need to write all of the test implementation code by hand, including all of the glue code, and that would be very time consuming. But we have a few additional avenues that we can take here. So for example, we can generate gherkin from a gRPC proto file. We can also scaffold the glue code and construct valid tests that just are pending any implementation that you provide later. So this essentially helps to vastly speed up the pace that test code can be written in a way that is friendly to developers, but without essentially demanding too much of them. So what this diagram shows is essentially how you can use the BDD CLI to enhance that process, where you can have multiple different sources of gherkin all coming together and assembled, using that with BDD glue to generate the native Cucumber test implementation code, then running BDD verify, getting it a test report with all the results, publishing that to a variety of sources. What's currently displayed there is TestRail, QE triage, Jenkins as well, although that's not strictly speaking part of the BDD CLI, but it is a feedback tool in a sense. And there's also a bucket there with a bunch of question marks, but that's essentially because your use case may vary. You may decide that you want to publish to someplace entirely different. And so, and because we're developing additional modules to enhance this process and to improve observability, this is one of the things that we're keeping in mind. This process could happen all locally. It could happen in a CI environment, pre-merge, post-merge, it doesn't matter. This helps to create a BDD process which improves collaboration for a number of teams. And that includes developers, testers, TPMs, and architects. And so you might also think, where would this fit into a deployment pipeline today? What you see here is essentially a generic pipeline which can apply to any microservice where you're deploying to multiple different environments. It's happening post-merge, and there are a number of quality gates for each phase of the deployment. And you might have contract tests, you might have a canary analysis, which is happening for a canary style deployment. And you also may have API tests or functional tests or acceptance tests. And we think that that happens to be the optimal place to standardize this approach, because with a gRPC-based microservice, we can generate gherkin for that, generate the native test implementation code for that, and then run it. So this happens to be a great place to standardize our approach. What we're planning to do, in fact, is exactly that. We're going to push for BDD adoption across the microservices at SiriusXM Pandora. And we're also planning to open source the BDD CLI and its supporting components, the tools and libraries that it uses, among them the glue generator, the proto gherkin, as many components as we can, essentially. So some conclusions we'd like to leave you with. One is to focus on testing behaviors. That's the common theme for both TDD and BDD. Where BDD differs a little bit is in its emphasis on fostering collaboration, but do note it does have some overhead risks if not applied correctly, or if the risks are not properly addressed. But we do believe that with a standard approach, by adopting tools like those that we've presented here, that can help to mitigate the risk and also to improve the developer experience. And with such tools, we also expect that this will help achieve a much higher level of observability on test coverage, especially with the BDD CLI, the standardization that provides, and with the ability to extend that with publishing modules, depending on whatever that our intended use case might be. So I'll also note as well that we are hiring. So here are some links to those recs. We have our LinkedIn's here for myself and for Rob, so feel free to network with us if you'd like. And also the Pandora Media GitHub organization link. We have not open sourced our components yet, but we will be posting them there, so please stay tuned. And with that, I'll say thank you. Thanks to Sauce Labs for the opportunity to present to you today. And stay safe. Have a nice one.
Thank you.